run the code, and the server will start running. What does that all look like once you hit upload on that? Well, we actually go to the notebook, and then I hit run. See? What it'll do is it on the back end. See, it's actually running the Python script execution. It actually ran the Python script in the HTTP server. So what happened, and then what did it print out? In this case, it printed out the same thing, right? So it printed out label, whatever. So how did it know how to do that? All that plumbing stuff I showed you earlier is how. It knew. So what happened there was you had the pipeline host name. Where did that come from? That came from here. So that mapping automatically happens. So as long as you run the container or the notebook inside the Docker inside Docker Compose, it actually automatically sets up a network and maps all the host names and everything for you. So for local development, it's really nice. So there's a lot of other stuff in here with the volumes, as I mentioned. So the volumes is where you say, take the current directory / input data and mount it to this path, right? And then what you can do is you can specify something called an entry point. You don't have to know most things about this, just know that this starts the server essentially. But one thing you can note is that it starts the config.json, right? So you specify USR share input data. So why did that work? Because it's a mounted volume. That's why that worked. So that's why I'm able to take the input data here, right? And I say this path is mounted in the container, and you specify a config path, and that absolute path is then used whatever is used locally there. You use that's what you use volume for. Use it for any data you want to retain. So this is a general concept in Docker. So you do Docker run -v, same thing. Docker Compose just does all that for you. So there's some other stuff in here that I'll just briefly cover. Make sure again you can upload that. Make sure you can upload that client notebook, and make sure you can go to that token.
Yeah, I'm getting permission behind error when I'm trying to upload the notebook.
Permission? You're probably in the wrong directory. That's why. Make sure, you're in the wrong directory. Go to the root directory. Yep, make sure you upload the root directory. So you just go to cancel. Go to upload.
So you upload.
Yeah. Upload in the root directory. Yep. Always upload the root directory. You just do that. Open. Upload. See? Yep, you're good to go. Yeah. So one other thing I should cover here is ports. So as I mentioned earlier, ports are another concept. Right? So ports, what I'm doing is I'm mapping the container port 65535 to the local port 65535. That's how you expose a port. So why do we do this? It's because what happens, right, is you have a bunch of you might want to remap the internal static port here to another random port that's not going to clash with something in your machine. So that also allows me to access everything via localhost. So if I go there, so what's another thing I can do? So there's a another one. It's a dashboard. It's a dashboard thing called Grafana. So I'll just briefly mention what this is. So if you want to track things in real time, see, inference time goes up, down, etc. Right? So this is actually all being updated in real time. So you can dynamically create metrics and things like that. So if you're wondering what this is called, or if you're wondering what this is, what this does is this uses something called Prometheus. So Prometheus is actually a spec for collecting metrics. So what I can do is I can go to the model server itself. See, I can actually go to the model server itself and collect a bunch of metrics. Like so, if you're ever wondering what monitoring in production looks like, just go to localhost 65535/metrics, and what are you going to see here? You're going to see memory allocation, warnings, errors, debugging, JVM stuff. Don't worry about it. Batch creation time, so like the amount of time it takes to create. In this case, since we're in Python, we're actually not creating a batch, so we don't track that, right? But we also have things like system load. So these are the things you typically use when you want to predict when a system's overloaded. So for example, if you want to predict, so something that typically happens, for example, is say you send 1,000 images at once, and you want to track GPU usage, right? Like, oh, all my GPU memory is taken up. You track it with something like Prometheus. Why do you track these things? It's because otherwise these systems hang and you don't know what happened. So how do you know what happened? You track everything, right? Like so, in this case, Pipelines actually has a few different components in there. So like, for example, we integrate with something called NVML. So if you want to do GPU monitoring, NVIDIA's SDK in C that gives you all the GPU metrics in your desktop app. We directly expose the same thing in C from C. So you don't need to worry about it, but somehow it appears here, right? Like so that's all prepackaged with the server. So not only system load, but GPU metrics, all sorts of stuff like that. So in general, what we then do is we then take that and we put it into something like Prometheus or Grafana. So Grafana. This is actually open source. So they have they support a lot of different query sources, and they basically dynamically allow you to create like any kind of dashboard you want. So rather than using matplotlib, you can just use Grafana instead. So you can just go here and then you can dynamically create dashboards and you can import. So when I import, what I'm going to do is I just have a file here, right? And then I just have a dashboard.json. Hit open, and then import, and then it'll be the same thing. And then I have like system load and all the other fun stuff like that. Right? Like so, if you want to do production monitoring, you typically use something like this or the elk stack. So I'm not going to spend too much time on this. This is mainly for system administrators. But if you're curious about like what's out there, this is just one of these examples. So again, what is this for? You're in production. You need to know, when is my model going to run out of memory? What do I do? You use tracking. Okay, so let me make sure that people have their. Yeah, go ahead.
Right now, you're just using a static file, right?
You use what?
A static file, the dashboard.json.
You could, but then your business department's going to want to know about metric X, metric Y, metric Z. You're going to want to mix and match different things. That's what these kinds of things are for.
So right? How do you map this to a real-time input from the source?
So in this case, you actually directly map it. So that's already all pre-configured in the dashboard. You choose a visualization and a query. So what happens is you choose Prometheus, and then Prometheus has a configured what's called a scraping time. And then what it'll do is it'll hit this endpoint every time. So you hook it up, and then every like so many seconds, it grabs this and then directly updates it in real time. So Prometheus is the key though. So Prometheus is a time series database. Also open source, free, etc.
So can I not use Prometheus within Matplotlib if you want?
So you could. So it actually has a Python SDK. So if you want to do that, you can, yeah. So you can just expose that metrics endpoint and then use Matplotlib. In practice, systems administrators need something more robust. But if you just want to play around with it, then yeah, you can just have that metrics endpoint and then use the Python SDK automatically. And then you can use Matplotlib for that. Nothing's stopping you from doing that. So what I like about Prometheus is it supports like most programming languages, and most real monitoring systems, including Kubernetes itself, implement this. Either that metrics format. Most time series databases actually directly support that format now. So anything that has that format will work. Like I said, most real DevOps systems will actually use this. And again, all you have to do is you specify that /metrics endpoint, you're good to go. And then Grafana is a default for a couple different. So us and Celdon both use Grafana as kind of the default charting library. Kubernetes, I believe, Kubernetes itself also, I believe, has a few examples that use Grafana. It's kind of just, it's nice to use, and it's a lot simpler than Stack. That's why a lot of people use it. Because Stack is like a beast to set up normally. Like Elasticsearch and all the other stuff, that's generally like a little difficult to set up. But Elasticsearch also supports Prometheus as well, like that format. So if you have Stack, you can use that as well. Make sense? Okay, now let's make sure at least that people can. So can people run their notebooks now? Like you can go to localhost. Okay. So let's spend a few minutes cleaning that up first. All right, what do you got?